quick refresher on what we talked about yesterday. Remember we talked about there's two forms, right? There's two forms of these equations. The ones that are in the ax squared plus bx plus c form, where they have an x and an x squared. And this was called quadratic. And then ones where it was ax minus h squared plus k. And these are called standard. And so we worked through examples with quadratic. We said if it was in quadratic, we could get the vertex by doing negative b over 2a. Take that, plug that back in, and get the k. And then we found our intercepts by either graphing or using the quadratic formula and plugging in any extra points we needed. If it's standard form, and there's only the x squared, not an x and an x squared, then we get the vertex by doing the hk. We got the axis for both of them as x equals h, right? Axis of symmetry. And then we also found our y-intercepts. On the one on the right, we said y-intercepts, well, you could just plug 0 in for x. But on the right, you can also use your even root property to get the x-intercepts. So just realize that you can piggyback between these two methods, okay? And depending on the format of the question, I would say depends on how you want to approach it.
What's the a and what's at the bottom?
Axis of symmetry.
Okay.
Yeah.
Where 2a is equal to the vertex.
That's the x coordinate of your vertex,
Okay.
which I'm going to do first. So this is quadratic form, right? We have an x squared and an x. So for these to find the vertex, I do the negative b over 2a. So a is negative 1, b is 6, and c is negative 8. We don't need it now, but if we did the quadratic formula, obviously c would be negative 8. To find the vertex, I'm going to do negative 6, because that's negative b, over 2 times negative 1, because that's a. Negative 6 over negative 2 is 3. And that is the x coordinate of my vertex. Then I'm going to find the y coordinate of my vertex by plugging that back in. So the negative stays on the front. 3 squared plus 6 times 3 minus 8. I square the 3 first. It becomes 9. Then I take the negative, so it's negative 9 plus 18 minus 8. Negative 9 plus 18 is 9. Minus 8 is 1. And that's the y coordinate of my vertex. With me so far? That's the y. Once you plug it back in, you get the y coordinate of your vertex. Negative 9 plus 18 should give you positive 9, right? And then minus 8 is positive 1. Yeah.
And the 3 is the vertex?
The 3 was the x coordinate of your vertex. So the vertex itself is the coordinate point. Then I get my axis of symmetry, which is x equals the x coordinate of my vertex, or x equals h, which is x equals 3. And we have to have an x because it's an equation, so it's x equals. Nate, I'm almost there. I'll get there in a second. Questions so far? Okay, then I want to do my intercepts. So I'm going to start with, keep clicking, sorry. I'm going to start with my x-intercept. And to do that, I plug 0 in for y. So I plug 0 in for the f of x because that's the same thing as y. I get 0 equals negative x squared plus 6x minus 8. So x-intercept, I plug 0 in for y. Now I want to see if this is factorable. Okay, there's a negative on the front, so let's do first times last. Negative 1 times negative 8 gives me a positive 8. Are there factors of positive 8 that sum to positive 6? Yep, so this is factorable. So I get negative x squared plus 2x plus 4x minus 8. And I group them. Take out a negative x, and I get x minus 2. Take out a positive 4, and I get x minus 2. Take out an x minus 2, and I get negative x plus 4. set them each equal to 0, and I get x equals 2, negative x equals negative 4, x equals 4. So there are 2 x-intercepts, 2, 0, and 4, 0.
Can you also like take out the negative and put it in parentheses?
Sure. Yep. You could divide everything by -1. Same thing. Okay, then I'm going to find my y-intercept. And that's the easy one. I plug 0 in for x to get that. My advice is, look, if I plug 0 in for x here, 0, 0, it's just -8, okay? But if you want to see it work out, like exactly, the y-intercept, I'd get f of x, which is y, equals -0 squared plus 6 times 0 minus 8, 0 and 0, and I just get -8. If your equation is in quadratic form, then your y-intercept is just your c. If it's in quadratic form, if it's in quadratic form, which it has the x squared and the x, then your y-intercept is just the c, 0, comma c.
So if you write like y equals -8 and then like parentheses 0, -8, are those the same thing?
No, that's where you gotta be careful. So you want it to be 0, -8. Y equals 8 is actually an equation.
Okay.
Yeah. So the format on the intercepts is the coordinate points.
Okay.
Yeah. Sometimes people are not nitpicky about that, and some people are. You just gotta be really careful.
I missed the angle of symmetry.
Axis of symmetry is x equals the x coordinate of your vertex, which is h. So as soon as you know the x coordinate of your vertex, which is the negative b over 2a in this case, it's x equals that number.
So it's just x equals 3.
Yep.
Okay. How do you know the y of the vertex?
You plug the negative b over 2a back in,
What do you mean by it?
like into here for the x values.
Oh, okay.
Yep.
And on homework it says something about like x-intercepts, smallest value.
It just means put them in order. So like this one, the 2, 0 would come before the 4, 0. Because x, the 2, that's all it means. Which one's smaller? 2,
Oh.
4.
Oh, okay.
It just wants you to mark so that I can mark it right or wrong.
Okay.
Yeah. All right, so then I'm going to plot all this information. 3, 1 is my vertex. X-intercepts are at 2, 0, and 4, 0. Y-intercept is at -8, 0, which is all the way down here. Because the x squared was negative, which is usually the first thing we identify, right? It makes sense that this opens downward. My axis of symmetry would be the line that runs right through the vertex, which is x equals 3. All right, so in this example, we're going to find the vertex, the axis, the x and y intercepts, and then graph it, keeping it in quadratic form. So later we're going to learn how to put that in standard form, but for now we're going to keep it in quadratic, which means my vertex I'm going to find by negative b over 2a. A is 1, b is -4. So negative 4 over 2 times 1, and I get 4 over 2, which is 2. That's the x coordinate of my vertex. Plug that back in, 2 squared minus 4 times 2 plus 3, and I get 4 minus 8 plus 3, -4 plus 3, which is -1, and that's the y coordinate of my vertex. The axis is always x equals the x coordinate of my vertex, which is 2. Let's skip to the y-intercept because that's the easy one. If I plug 0 into here and 0 into here, the y is just the c, so it'd be 0, 3. To find the x-intercepts, we're going to take our equation, 0 equals x squared minus 4x plus 3. See if we can factor it. So are there factors of positive 3 that sum to -4? There are. X minus 3 and x minus 1. Set them each equal to 0. And I get x equals 3 and x equals 1. So my x-intercepts are 3, 0 and 1, 0. Now let's plot all that information. 2, -1, 3, 0, 1, 0, and 0, 3. And we've got enough information to graph our parabola. Our axis of symmetry would be x equals 2, which runs right through the middle. Okay, number 9, same thing. Find the vertex, the axis, the intercepts, and then graph. So I'm going to again keep it in standard form. Vertex, negative b over 2a. A is 2, b is 8, c is 7. So negative 8 over 2 times 2. Negative 8 over 4 is negative 2. That's the x-coordinate of my vertex. Plug that back in to get the y. 2 times negative 2 squared plus 8 times negative 2 plus 7. 2 times 4 minus 16 plus 7. 8 minus 16 plus 7. Negative 8 plus 7. Negative 1. Axis is x equals negative 2. Y-intercept, plug the zeros in, and I get 7. X-intercepts. So now I have to take 2x squared plus 8x plus 7, set it equal to 0. Multiply first times last. Are there factors of 14 that sum to 8? And there are not. So I'm going to have to use the quadratic formula. A is 2. B is 8. C is 7. Negative b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. Negative 8 plus and minus the square root of 64 minus, this is 8 times 7, which is 56 over 4. Negative 8 plus and minus 64 minus 56 is 8 over 4. Negative 8 plus and minus, this is 2 and 4, or 2 root 2 over 4. 2 goes into each of these, and I get negative 4 plus and minus root 2 over 2. Now that goes a step further to negative 4 over 2 minus root 2 over 2, and negative 4 plus root 2 each over 2. So I'm actually going to change this negative 2 minus 2 root 2 and negative 2 plus 2 root 2 over 2. So you can simplify it that way, or you can approximate it. So when I'm listing my intercepts, I would actually keep them as this. They would be negative 4 minus root 2 over 2, 0, and negative 4 plus root 2 over 2, 0. And you can approximate that to graph that, or you can plot additional points. So if I did negative 2, negative 1, I have my x, or my vertex there, and my y-intercept is 7. I can try to approximate this, or I can simply plug in some additional points, which is probably easier this time. So I'm going to take and plug in negative 3 and negative 1. 2 negative 3 squared plus 8 times negative 3 plus 7 is 2 times 9 minus 24 plus 7, 18 minus 24 plus 7, negative 6 plus 7, which is 1. So negative 3, 1. And I should get the same thing for negative 1. 2 negative 1 squared plus 8, negative 1 plus 7, 2, 1 minus 8. 2 minus 8 plus 7, negative 6 plus 7, which is 1. Now I can draw my parabola. If I had approximated that answer, it should have fallen between negative 2 and negative 3, and in between negative 2 and 1, or negative 1. But you can always just plug in some additional points to fill that graph. So there's the graph of my function. That should match what we just did, okay? If we want to check exact points, then you have two options. One is if you hit the trace button, it will literally allow you to trace along your curve to find your points. Now, if they are on the x-axis, they're not always exact. I don't know if you saw it, but when we started, it brought me right to the y-intercept, or the x-intercept. No, y, sorry. And it was a dead on. But as I get up to the x-intercepts, it skips it, okay? The second way is more accurate. So I hit second, trace, and it takes me to this menu which says calc. I want to find a 0. A 0 is the same thing as the x-intercept. So I hit enter, and it says, take me to left bound of that point. So as long as I get the curve left of that point, which is where it is, I hit enter. Then it says, take me to the right side of that point. So I go arrow to the right till I get past the axis. I hit enter. And then it says, are you ready for me to guess? And my answer is yes, so I hit enter. And it's going to bring me directly to that point. I'm going to repeat that process for the other one. Second, trace, go to my 0, go left now of the second x-intercept, hit enter. Go right of the second x-intercept, hit enter again, and it's going to bring me directly to that 0. So that's how you can find exact zeros, okay? It's how you can find, notice it says max and min, which we'll get to in a little bit, but all that stuff is using the graphing utility. If you don't have a handheld graphing calculator yet, I don't want you to freak out. You can also use the app for now because you won't be using this on a test. So I used my graphing utility to graph this parabola, which is the one we already graphed earlier. And I got this. It says find the vertex and the intercepts. So this vertex here was at 2, -1, and the intercepts are here at 1, 0, and 3, 0. So you can always use your graphing utility to check your graphs. So this is writing a quadratic in standard form using complete the square, okay? All of these steps we are going to do several times. I put them in words so that if you are stuck somewhere and you're like, I have no idea what to do next, hopefully these words jog your memory, okay? But we are obviously going to work through some examples. The goal here is to get from this form, quadratic, to this form, standard. So if we don't want to do the negative b over 2a method, how else could we graph it? Is we force it into standard form. And then from standard form, you can pull out your vertex and your axis of symmetry and all that stuff, okay? So this process is called completing the square. This is going to be the first part of what your video quiz is. So the first thing we're going to do is we're going to group together the ax squared and the bx. And we're going to leave a space because we're going to fill that in. We're going to bump the c to the outside. If there's a number or a sign, like negative, on the front of the x squared, we have to factor that out. So we would take it out of both of those terms. It's going to sit on the front. Then we have to fill this space with the perfect square trinomial. So we take the b, we divide it by 2 and square it. We're going to add that term to here, and we have to balance this equation, so we're going to subtract it from here. If we took something outside of the ax squared and the bx, then you have to multiply it times what's on the front first, okay? That's when it gets a little bit more complicated. And again, we'll work through examples, and I'll tell you, like, this is on level with what you see in your quiz, and this is not, okay? Then what the goal is to make this parentheses a perfect square trinomial, so we're going to factor it. To factor a perfect square trinomial, we square root the first term, we square root the last term, we take the sign from the middle, we put it in parentheses and square it. And when you are done with that, you have forced it into standard form. So you are changing your equation from quadratic into standard. Again, I'm going to work through several examples of these, but if you are at home and you're like, crap, I don't know what to do next, this slide is supposed to help you. Is it going to teach you how to do it by yourself? No. That's where practice is going to come into play, okay? So this direction says put the equation into standard form, then find the vertex, y-intercept, x-axis, and x-intercept and axis. This will be the exact directions on your quiz. So now this is, you know how yesterday I told you to skip all those first parts of all the questions? All the first parts of the questions is the complete the square, which is what this is. So I'm going to take this equation, okay? I'm going to group together the first two terms. Leave a space, bump. This time it's a -3 that goes to the outside. Whatever the sign is goes with the c. Is there a number or a sign in front of the x squared we have to take out? No. This is when we're like, hallelujah. Okay? So now I look at the middle term. I'm going to ignore the sign for now because I'm always going to square it, which means it's always going to go positive. I just need to take that number. Take the number, divide it by 2, and then square it. So what is 6 divided by 2? 3. 3 squared is 9. That is the number I am adding here and subtracting from outside the parentheses. I can't just change the value of this equation. I have to balance it out. So whatever I do inside the parentheses, I have to do the opposite outside the parentheses. Now I'm just going to rewrite it with simplifying the negative 3 minus 9, which is negative 12. Now the goal was to make that parentheses a perfect square trinomial, so now I need to factor it. Y equals square root the x squared, it's x. Square root the 9, it's 3. Take the sign from the middle, which is minus. Put the squared on it. And then don't forget your minus 12. We're done. We just took something that was not in standard form and we put it into standard form. This is standard form. From here, we should be able to easily get our vertex. Do you remember how to do it? Say again. What if it's in standard form? Just the opposite of what follows x, and then the number that's outside by itself. So this is 3, negative 12. So there's the payoff. The payoff is I don't have to do the negative b over 2a. I could just pull that information out of it.
You don't take the negative from the
No, it's always the opposite sign of what's inside the parentheses.
So like if it was positive 3 would be negative.
Correct. What's my axis of symmetry? So close.
Negative 3.
Nope. The sign wasn't wrong.
X.
X equals 3. Don't forget it. Yeah. X equals 3. It's the most common mistake, and it will cost you, so don't do it.
And make sure you always include.
Correct, because it's a line.
Oh,
Yeah, it's a vertical line, which is an x equals. All right, check vertex, check axis. Now we've got the y-intercept and the x-intercept. For the y-intercept, you want to go back to the quadratic form. Because if I just plug zeros in there, remember it's just the c. So the y-intercept is 0, negative 3. If you don't believe me, plug the zeros in. 0 squared minus 6 times 0 minus 3. Gone, gone. And it's just negative 3. So for the y-intercept, it's way easier to go back to the quadratic form. You could also take this one and plug the 0 in and solve it. You'll still get negative 3. It's just a lot extra work. Still with me?
wait, so how'd you, the negative 3 is just the,
So if your equation is in quadratic, which is what this is,
oh, okay.
the y-intercept is just the c. But if you plug zeros in, that's how you would find it. You would plug a 0 in for x.
So it's just C.
Yep, well, it's 0 comma c, but yeah. Okay, now I got to find my x-intercepts. And you have 2 choices. 3, really. If the initial question is factorable, I can go back to that question, factor it, find my 2 x-intercepts. There are not factors of negative 3 that sum to negative 6, so this is not factorable. Our other 2 options are either use the quadratic formula from my initial equation or use the even root on our standard equation that we just got. I'm going to show you both. So on the standard one we just got, which is here,
What are we looking for?
the x-intercepts, I would say 0 equals x minus 3 squared minus 12, and I want to solve for x. So I add the 12. I square root both sides, putting a plus and minus in front of the root 12. And I add the 3. So I get 3 plus and minus the square root of 12, which becomes 2 root 3. So there are two x-intercepts. 3 minus 2 root 3, 0, and 3 plus 2 root 3, 0. So I would approximate the square root of 12 and then do 3 plus the square root of 12 and 3 minus. You're going to have a calculator at home. Try it. Figure out square root of 12 is, right? It's in between square root 9 and square root 16. Take 3 and add and subtract, 3.5? And you'll get the other points. So I'm going to also show you quadratic form because that's your other option. A is 1, B is negative 6, C is negative 3. So negative B plus and minus the square root of B squared minus 4AC over 2A. Negative B is 6 plus and minus the square root of negative 6 squared minus 4 times A times C all over 2 times A. 6 plus and minus the square root of 36. Negative 4 times negative 3 is positive 12 over 2. 6 plus and minus square root of 48 over 2. 48 is 3 and 16, so 6 plus and minus 4 root 3 over 2, which becomes 3 plus and minus 2 root 3. Same answer, different method. You choose it. I obviously think the first way is easier, but if you like the quadratic formula, go for it. So then once you get that information, and it doesn't say it this time to graph it, on your quiz, the last thing you'll do is graph it. So you'll get a graph. You would label your vertex, 1, 2, 3, negative 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's say it's down here. Y-intercept, 0, negative 3. X-intercept, so this is what we're going to approximate. I would do 3 plus and minus the square root of 12, and I would say the square root of 12 is in between square root 9 and square root 16. You can use a calculator to approximate that. So let's say it's plus and minus 3.5. I would get 3 minus 3.5, which is negative 0.5, and 3 plus 3.5, which is 6.5. And then I would connect all those points to get yourself your parabola.
Is the one in our quiz gonna have like, for the x-intercept, is gonna have like square roots and stuff?
Yep.
The one for the quiz is it gonna have a number on the outside?
No. So it is like on level with this.
Okay.
Yep. Don't worry, we're gonna keep practicing. Let's do another one. Put the equation in a standard form, find the vertex, y-intercept, x-intercept, and axis. So what's our first step? Group the first two together. So y equals x squared minus 4x, leave the space, bump out the 7, negative 7. Nothing on the front again to take out. So I go straight to the second term. That is a 4. Divide the 4 by 2 and then square it. 4 divided by 2 is 2 squared, that's 4. Add the 4 inside the parentheses and subtract the 4 outside the parentheses. Rewrite it. Y equals x squared minus 4x plus 4 minus 11. Now I made a perfect square trinomial, so let's factor it. Square root the first term, square root the last term, take the sign from the middle, put it in the parentheses, don't forget to square it, and don't forget your minus 11.
We don't need the middle term for this, for the...
When you factor it, you're finding out what factors of 4 sum to -4, right? So it would be -2 and -2. You'd have 2 of the same. So it's the same thing as writing as, but you're making it a perfect square trinomial, so it will always be a perfect square trinomial. Square root first, square root last, take sign from middle. In the parentheses, square it. So square root of x squared is x. Square root of 4 is 2. And the middle sign is negative. Okay, so now we have our standard form. That's half the battle. Then we find our vertex, which is what? 2, -11. So we change the sign on the one inside, but keep the sign on the one on the outside. What's the axis of symmetry? So close. +2. Good. It has to run through that point. So if it's different, it doesn't work, right?
Wait, so why do we keep the sign negative for the other side?
Because think about transformations. When the number was inside the parentheses, we did the opposite direction, right? If it was positive, we went left. If it was negative, we went right. But the number's outside, we go in the direction it means. So if it's positive, we go up. If it's negative, we go down. So we change the one on the inside, but we keep the one on the outside. Okay. Yep.
Let's just say it was at like 2x squared plus 1 or something. I forgot how to do that where like you go up and it's like the same direction, right? But like without the parentheses.
Without the parentheses. Say that again.
Because on the homework and I didn't. It said like 2x squared minus 1.
Oh, if there's no variable. There's no second variable.
Right.
Right, so there's no horizontal switch. You're just trying to,
0, 0.
so you find your 0, which, I mean your vertex, 0, 0, and then go right one and left one, plug those in.
Okay.
Yep. Okay, so now y-intercept, do the easy one, right? What happens when I plug 0 into x at the beginning? I get what? -7. X-intercept, not as fun, okay? Well, there's no factors of -7 that sum to -4, so I'm going to use my standard form. I'm going to say 0 equals x minus 2 squared minus 11. Add the 11. Square root both sides, putting a plus and minus in front of that 11. And then add the 2. So 2 plus and minus square root 11 equals x is my x-intercepts. And there's 2 of them, 2 minus square root 11 and 2 plus square root 11. So I found all the parts that this question asked for. If I was going to graph this, I would graph the vertex, go to the right 2, down 11. I would graph my y-intercept, which is at 0, -7. And then I would plot my 2 x-intercepts by approximating square root 11 to be like 3.5. And then do 2 minus 3.5 and 2 plus 3.5. Questions on this example? Correct.